So welcome to class today, students. We are looking at symmetry today from our previous lesson. In our previous session, we considered line of symmetry. So line of symmetry basically means that you have an object and you put a line that can divide your object into two equal parts, showing two portions that fit or match into each other. So here we have an example of a line of symmetry in our rectangle. In a rectangle, we can put two lines of symmetry like we have done over here. That means that if you are doing a vertical line of symmetry, it means this half is equal to that of the other half. If you are also doing a horizontal line of symmetry, it means the top portion fits into the bottom portion. Okay, so this is an overview of what a line of symmetry actually is. In today's lesson, we are looking at recognizing rotational symmetry. So first of all, we understand symmetry. The new word that is coming up today is rotational. Rotational is from the word rotate. That means it is moving around, okay? It stands at the same spot, but it turns around, okay? So we're going to look at how we can recognize rotational symmetry. We have these two objects here that we're going to use to demonstrate to you how rotational symmetry acts or happens. So with our rectangle, we're saying that a rectangle is having two order of rotational symmetry. And what is order of rotational symmetry? Order of rotational symmetry means the number of times an object or a shape turns around and still looks the same. So if you have a rectangle, you can actually move it in two turns and then you have a complete turn of that particular rectangle. So your first turn, it means this portion or this side is going to point up, and then the long part is going to point on this direction. That means you have done one turn. And then the other turn is when you have your rectangle like this, as we have on the board. So it means we can do two order of rotational symmetry. If you look at our bottom here, it's having four holes here, and then it has a central point. If you turn it one point, these two will come up here, so that is one. If you turn it again, these two will also move up, and then we have two. So you can actually turn this bottom in 4 times to have a complete turn. So moving it in 4 times to have a complete turn becomes order of rotational symmetry. That means you can move it 4 times to have the order of rotational symmetry. I hope that is clear for you. Okay, let me take it one over. If you have your rectangle, this is the first look of our rectangle. We can turn it one more so that this short side will go up and the long side will come at this very place. That means we have done one turn. If we turn again, we're going to come back to this very shape, whereby the long part is going to be on the top and then the short part is going to be on the vertical, as we see here. So that means that we can actually turn this shape 2 times and we'll still have our rectangle to look exactly as a rectangle, having 2 lines of symmetry inside it. That means we have done 2 order of rotational symmetry. Each time you turn an object, it is an order. Each time you turn it, it is an order. So a complete turn and the number of turns that you make will complete your order of symmetry that you have. Okay, I hope that is good for you. Okay. So we have a second example that we're going to look at before we go to our task 1 for the day, because our task 1 is also going to be on rotational symmetry. So we'll use a parallelogram as an example, and with a parallelogram, this one that we have, it cannot take any line of symmetry, so which means we cannot put any line of symmetry inside, but we can put a rotational symmetry. So a rotational symmetry here in its sense means that we can turn this parallelogram and it will still look the same. So how many times can you turn this and it will still look the same? It's having the features of a rectangle, just that this is in a slanting form. So if you turn it 110, this side is going to go up and here is coming to come down. And you have this side standing straight like this. It still looks like a parallelogram. So nothing changes with that when you make a turn like that. That means you have done one order. If you turn it again, it also gives you the shape that we have here. So in its sense, this will give you 2 orders of, so this will be equal to 2 order of rotational symmetry. Okay, so this will give you 2 order of rotational symmetry, which means you can turn it in 2 forms to complete a rotation, and that will give you the order of rotation. Okay, now let's look at our trapezium. With the trapezium, it can take 1 full line of symmetry if this side is equal to that of the other side. But how many order of rotational symmetry can this one take? It can actually take just 1. So this is equal to 1 order of rotational symmetry. Okay, so a trapezium will give you 1 order of rotational symmetry, whilst a parallelogram gives you 2 of the order of rotational symmetry. I will then move you to your task 1 for the day. You are doing exercise 8.3 on pages 91 and that of 92. We are doing questions 1, questions 3, and that of questions 4. Okay, I hope that you can apply the knowledge that you have learned from this session and solve these questions. Thank you for joining this session. I hope to see you on our second video. Goodbye. Hello students, welcome to our second video on our lesson symmetry. We are treating the subtopic of symmetry as recognizing rotational symmetry. In the first video, I explained to you what is a rotational symmetry and that of order of rotational symmetry. So rotational symmetry means an object or a shape that can be rotated about a point to another position and still looks the same. That means you are doing a rotational symmetry. The number of times that you can rotate these shapes and still have the look to be the same, it's what we call the order of rotational symmetry. Okay, so this is the movement. The rotation is the movement, and the number of times that you move it is what we call order of rotational symmetry. So you have to know the difference between rotational symmetry and order of rotational symmetry. Okay, as I am moving this object, it means that I am doing a rotational symmetry. But the number of times that I move this to have a complete turn is what we call the order of rotational symmetry. This is something that I want you to understand with this particular topic of recognizing rotational symmetry. Okay. We will move to our second activity, which is our task 2, and we are doing exercise 8.3 on page 48. We are doing questions 1 and 2, and you can find this exercise at the Skills Builder book section of your textbook. I hope you have enjoyed this section and you have followed me up to the point, and I'll see you in our third video. Goodbye. Hello, welcome to our final video on our lesson Symmetry, recognizing rotational symmetry. We have looked at a rectangle, how many order of rotational symmetry that a rectangle has, and the answer is 2. And then we look at a bottom that is in the form of a circle. So how many order of rotational symmetry does this bottom also have? It's 4. Okay, so these are the different order of symmetry, rotational symmetry, that we can find with a particular object that we are dealing with. To also elaborate more on the difference between rotational symmetry and that of order of rotational symmetry. First, rotational symmetry means the movement of the shape from one position to another that still make the object looks the same. And then the order of rotational symmetry is the number of counts, the number of times that you move this object from one position to another and still looks the same, to have a complete turn around. Okay, so some objects or some shapes you can move it like 2 times and you have your complete turn. Some objects you have to move like 4 times to have a complete turn, depending of the shape that you are dealing with. Okay, so these are the 2 differences of a rotational symmetry and that of order of rotational symmetry. On this video, we're going to have our homework for the day. So our homework will be exercise 8.3. That will be at page 48. There's actually one question there that comes with sub questions over there. You can find this exercise or this homework at the challenge book section of your textbook. I would like to thank you for joining this section today, and I hope to see you again same time next week.